This is APAB, and we are continuing with basic differentiation in 2.2. All right, so in example 4 and P4, what we're looking at here is products and quotients that we can't differentiate as products and quotients yet because we don't know the product rule and the quotient rule, but also that we shouldn't differentiate as products and quotients anyway because the smarter way to do these problems is to simplify algebraically. So I'm going to walk through E4 with the product in part A and then a quotient in part B. I'm going to simplify those, and then you're going to try P4, and then we'll go over that too. Okay, so the first thing to recognize is that this square root of x is actually an x to the 1/2, right? So when I distribute that, I'm essentially multiplying everything in the parentheses by x to the 1/2. So I'm going to go ahead and write algebra first, because I'm not doing calculus yet. So I'm still going to say f of x, because it's not f prime of x, it's f of x. When I distribute this x to the 1/2 to an x squared plus 3, when you multiply two exponential expressions with the same base, you add their exponents. So my exponent is going to become an x to the 5 halves, right? Because 1/2 plus 2 is 1/2 plus 4 halves, which is 5 halves, or 2.5, plus 3x to the 1/2. So now, sorry, kind of messy, got worse. All right, cool. All right, so now I can do my calculus, right, which is that my f prime of x is going to end up being, I drop the power down in front, so 5 halves x to the, now I'm going to do 5 halves minus 1, which would be 5 halves minus 2 halves, so that's going to be 3 halves, right, plus I drop the 1/2 down in front, so I'm going to get 3 halves x to the negative 1/2. Now you can rewrite that if you want. You can put the x to the negative 1/2 on the bottom if you want. You can change things to roots. I'm going to argue that that answer is probably fine. The other way that you could see this answer, in theory, is that you might see this term as a 3 on top of a 2 root x, right, because it would be an x to the 1/2 on the bottom. I don't expect that you'd actually see the x to the 3 halves rewritten, to be perfectly honest, and I think this answer is totally fine. Remember, as we move forward in calculus, we're mostly simplifying selfishly, right? We simplified because it makes our lives easier, and in this case, this doesn't really make my life a whole lot easier. So, all right. For B, I have a quotient, right? Now, there's two ways to think about this problem. I don't care which one you prefer. One way, so I'm going to do the algebra in two ways, not because you have to, but because I want you to see that there are two logical ways to reason through this problem, and then you should pick the one that makes the most sense to you. Either, because this is a monomial, I can split each one of these terms up into that term divided by my divisor. So x cubed over x minus 5x squared over x minus an 8 over x, right? Which means that my f of x, again, I haven't done any calc yet, would be an x squared minus a 5x minus an 8x to the negative first, and now I could differentiate, right? So if I did that, my calculus would be that f prime of x equals a 2x minus a 5 times an x to the 0, but we just don't bother to write that, plus an 8x to the negative second. Now this one you probably would see rewritten as a 2x minus 5 plus an 8 on top of an x squared, right? So that's probably the answer you're going to see. Now I said I was going to show you the algebra in two ways. Here's the other way to logically think about the algebra. It doesn't change the calculus at all, it just changes how you get to here. The other way to think about this is as a net x to the negative first times this entire numerator. Okay, and if you thought about it that way and distributed it, you're going to get to this same step right here, right? If you distributed the x to the negative first, x to the negative first times x to the third would give you an x to the second, x to the negative first times the negative 5x to the second would give you a negative 5x to the first, and x to the negative first times the 8 would give you an x to the negative first. So either way you think about it, whether you think about it as splitting up the fraction or whether you think about it as distributing an x to the negative first, it's going to get you the same answer. And then you differentiate, and this should be your answer. So pause me if you want. I'm going to go ahead and walk through P4. And again, if you want to do it before I do it, you should pause me now. All right, so I'm going to start by doing the algebra, right? The algebra is that I'm going to distribute this x to the 1/2, right? So x to the third is actually x to the 6 halves, right? So I'm going to get that my f of x is an x to the 7 halves, right? Because it would be 6 halves plus the 1/2. Plus a 5x to the 3 halves, right? Because x to the first is actually already at 2 halves, so when I add 1/2 to 2 halves, I get 3 halves. Now I can do my calculus, and I'm going to get that my f prime of x is a 7 halves x to the 5 halves, right? Because I subtract 1 from 7 halves, which would be 2 halves from 7 halves, plus a 15 halves x to the 1/2. And again, you might see that rewritten with the x to the 1/2 being a root. Sorry, I kind of wrote over the 5 there, my bad. Okay, but I think that it's pretty much fine the way you see it. For the second one, and I am going to erase to give myself a little space because I kind of crammed in E4, and there's no logical reason to do the same thing for P4, so I'll give myself a little bit more space for P4B. So for P4B, again, there's two logical ways to think about this. You can either, so when you do this algebra, you can either do this algebra by splitting everybody up over the x squared, which is totally fine, right? Or you can think about it as distributing an x to the negative second, right? I promise that either of these logical ways of thinking of this is going to give you the same answer. It really doesn't matter. So again, this is my f, not my f prime, right? If I do this algebra, I'm going to get that my f is an x squared minus a 6x plus a 5x to the negative second, and I assure you that you get the same answer if you do it the other way. What that means is that my answer to P4B is f prime of x equals 2x, right, because I dropped the power down, minus 6 minus a 10x to the negative third, so the answer you're probably going to see is 2x minus 6 minus 10 over x cubed. Right, and there's your answer, okay? All right, so one thing I want to touch base on, because I know it can be a little bit of an issue for people sometimes, are problems that look very, very similar but are actually different because of grouping symbols, right? So what we're going to do, we're going to call it example 5, right? But I'm actually stealing sort of a mix of problems from the book that are similar. So that are in example 5 and example 6, right? So let's, okay, so here's what we're going to do. We're going to look at some problems that are similar to one another, but aren't the same, and look at how they would come out different. Okay, so for all of these, we're going to find f prime of x, but I want to show you a couple different options. So we're going to, so for A, I'm going to give you that f of x is 4x squared over 3. And for B, I'm going to give you that f of x is a 4 over 3x squared. Okay? For C, we're going to do an f of x equals, let's do 8 over, let's do 3x to the negative second. And let's, for D, do an 8 over a 3x to the negative second. Okay, so the reason I'm giving you these, I want you to see subtle differences in the way that these things are written that make a difference in the way the problem's going to work, right? So in A, right, so in all of these, the best thing I can do first is to rewrite the function using algebra, right? And then before I do any calculus, right, then I'm going to differentiate, and then I'll clean it up if I need to, right? So for A, the 4/3 is in front of the x squared. The 4/3 is a coefficient in front of the x squared, right? So when I differentiate, I'm going to get that my f prime of x is going to be, I drop the 2 down in front, I'm going to get an 8/3 x to the first. And that's it, right? No rewriting, no anything, it's fine. Now for B, though, this guy's on the bottom. I want to leave the 3 on the bottom. The 3 is actually not partnered with this, right? So I'm going to have a 4/3, but when I flip the x squared up to the top, it's going to become an x to the negative second. So now my f prime of x, right, my f prime of x is going to end up being, I drop the negative 2 down in front, I get a negative 8/3, x to the negative third. So chances are my final answer is going to look like a negative 8 over a 3x cubed, right? That's probably the final answer I'm going to land with, right? Now, for C and D, there's an important difference here, right? The important difference for C and D is basically whether this 3 is included in that negative 2 power, right? So for C, this entire expression can get flipped up to the other floor because of that negative exponent. So this is the same as an 8 times a 3x quantity squared, which is an 8 times a 9 times an x squared. This thing is a 72x squared, right? So that means that my f prime is just going to be 2 times 72, right, which would be a 144, x to the first, and that's it, right? Here, the difference is that only the x to the negative second has the power. So this is actually an 8/3 times an x squared, right? The x squared gets flipped up, but not the 3. So my f prime of x is going to be a 16/3 times an x. Okay, so just note the difference. It does, like, things like parentheses matter. Note where the x is, it matters. That's kind of the point. So now we're going to do, let's do a P5 that's similar to E5, right? Just, again, to get sort of the point about dealing with some of these parentheses and stuff. So I'm going to erase these guys. That's why redo everything. All right. So, let's do, I don't know. Let's do an 11 over a 2x squared, and an 11 over a 2x quantity squared, and let's do negative 5 over 4x to the second, and let's do negative 5 over 4x. Okay, I was kind of lazy. I picked a lot of 2's, but it's all right. Okay, so give this a try. Pause me if you want, or just do it with me. So, cool. So in this one, notice that the squared is only on the x, right? So if I flip this up, it's going to be an 11 halves x to the negative second, which means that my f prime of x, I'm going to drop that negative 2 down in front. I'm going to get a negative 22 halves, but that's just a negative 11 x to the negative third, right? And so I'm going to go ahead and make this a negative 11 over x cubed, right? Cool. For b, though, the squared is on both of these. So this is actually an 11 over a 4x squared, which means that when I rewrite it, it's an 11 fourths times that x to the negative second. So now my f prime of x is going to be a negative 22 fourths, which I could leave as a negative 22 fourths, right, if you want, x to the negative third. Or you could simplify and make it a negative 11 halves. It doesn't really matter. So you'll probably see it as a negative 11 over a 2x cubed. That's probably what you would see, but you might see it as a negative 22 over 4 with the x cubed on the bottom. For this one, note that only the x to the negative second has the power, not the 4. So this is a negative 5 fourths times an x squared, which means that my f prime of x is going to be a negative 10 fourths x, or you might see it as a negative 5 halves x. Either of those would be fine, right? And then for this one, note that both of them have that power. So this is actually a negative 5 times a 4x quantity squared. Well, that's a negative 5 times a 16 times an x squared. That's a negative 80x squared, which means that your f prime of x would be a negative 160x. Okay? So again, just to show you, all of this is algebra skills and all of this is calculus skills. And so one of the things people find most daunting about calculus is how much algebra and trig is involved. You really have to stay on top of your algebra skills. Okay?